determining holes, and intro to horizontal and slant asymptotes of rational functions. I left off with going through some examples determining holes, and I have just a couple more to do before we discuss our horizontal and slant asymptotes. So remember, holes, we are going to look for any factors that reduce, so we first have to factor. I notice in the numerator there is a GCF of x, leaving me with an x squared minus 16. That was x cubed minus 16x. In the denominator, I have 3x squared minus 9x. I notice that it has a GCF as well of 3 and x, leaving me with an x minus 3. I can further factor the numerator, even though I see a whole already. We'll see if there's any more. X squared minus 16 is a difference of two squares. So I'll write the numerator factors as x multiplied by x minus 4 multiplied by x plus 4. Denominator remains 3x multiplied by x minus 3. So again, when I'm looking for a whole, I'm looking for a factor that is identical in the numerator and the denominator. I can simplify both of the x's in the numerator and denominator. So I would set that factor, x, just equal to 0 to get the x coordinate. So the x coordinate of my whole in this case is just 0. When you substitute that value back into the leftover pieces of your function, so to determine my y-intercept, or y value, excuse me, I'm going to take the original function, x minus 4, and x plus 4 that are in the numerator divided by just 3 multiplied by x minus 3. Remember, I only reduced the x. That leading coefficient of 3 stayed out there. Replace all of the x's with a 0. So this would give me 0 minus 4, which is negative 4, multiplied by 0 plus 4, which is positive 4, divided by 3, multiplied by 0 minus 3, which is negative 3. So I have negative 4 multiplied by 4 to give me negative 16 over 3 multiplied by negative 3 to give me negative 9, which works out to be positive 16/9. So the whole is actually really a y-intercept as well, which would be the value 16/9. So that's why we won't truly have a y-intercept, because we have a whole that takes over. Last example for holes. This one's about as simple as they get. Numerator x does not reduce. Denominator negative 4x plus 4, I can factor it a negative 4 or a positive, leaving me with a factor of an x minus 1. Do I have any factors that reduce? No. Not a single factor reduces. So in this case, there are no holes or no points that are removable. Discontinuity doesn't work, don't have any. You will have vertical asymptotes, that's it. You won't actually have a hole in your picture as you graph it. Okay, not going to work. All right, let's move on to horizontal and slant asymptotes. Again, I use that abbreviation LC for the leading coefficient, so I don't have to write it. In order to determine the horizontal or slant asymptotes, we're going to look at the degree, biggest exponents in the function, and the leading coefficients. So we have 3 different types. I can have a horizontal asymptote at y equaling 0. This means I have a larger degree in the denominator. For example, I could say y equals x squared over x to the third. Because the denominator is larger, it has a big bottom, I say y equals 0. That's where the horizontal asymptote occurs. Our next one is y equals the LC, or the leading coefficient. This happens when we have the same degree in the numerator and denominator. So let's say my equation is y equals 5x squared over 12x squared, and they could have other values on here. but I'm just looking at the degree of each of them. So in the numerator, I have a 5x squared. In the denominator, I have a 12x squared. That's the largest degree. Since it's equal, then my horizontal asymptote is just going to be the leading coefficients. Simplify them if you can. So y equals 5 over 12. That's it. You would find 5/12, somewhere between 0 and 1, draw on a horizontal line. Piece of cake. And last but not least, it is just to verify. We are not actually going to write the equations of our slant asymptotes. The slant asymptote is the regular y equals mx plus b form of a line, slope-intercept form. And this is when you have a larger degree in the numerator, so it's top heavy. So let's say I have y equals 4x squared just over x minus 1. Because I have the larger exponent in the numerator, the x squared term, it's top heavy, so we'll have a slant asymptote. And again, we're not writing those equations, just recognize it. And we're not going to graph those either through this lesson. Okay, determining if it's a slant asymptote or a horizontal asymptote. The first thing I want to do is check the degree. So I'm looking at the terms with the biggest exponents. Typically, there's going to be written in numerical order for you. So f of x is negative x squared plus 5x minus 6 over x squared plus x minus 6. I notice the first two terms, or first terms in the numerator and denominator, they're already there with the largest exponent. They have an equal degree. They are both x squareds. So in this case, we are going to use the leading coefficients. So my horizontal asymptote is going to be y equals the leading coefficient of the numerator, which is 1, divided by the leading coefficient of the denominator, which is 1. So y equals negative 1 over 1, which is negative 1. So if I'm sketching a graph at y equaling negative 1, I would have a horizontal asymptote, boundary line I never cross, drawn through the function. All right, next example, f of x equals x cubed plus x squared over negative 4x cubed minus 12x squared minus 8x. Again, looking for the biggest degree, the term in the numerator is x cubed. The term in the denominator is negative 4x cubed. They do have, again, the same degree, which is x cubed raised to the third power, so I'm going to use the leading coefficient. So the equation of my horizontal asymptote is y equals 1 over negative 4. Perfectly fine to write it like that. I always just put the negative in front of the entire fraction. So y equals negative 1/4. Means the same thing. You're not going to get it marked wrong. Means the same thing. Sketching this one, again, just a teeny bit below the x-axis at negative 1/4, I would have that boundary line that I don't cross. Next example, determine our horizontal asymptote. I have f of x is x squared minus 3x minus 4 all over 4x. I'm looking for the term with the largest degree, largest exponent, and I'll check that out first. So I have an x squared in the numerator and an x, 4x to the first in the denominator. All right, in this case, the numerator degree is larger than the denominator degree. In this case, we have a slant asymptote. So our answer said determine the horizontal asymptote, so we can say no horizontal asymptote. Okay, next example. F of x equals x minus 1 over negative 3x squared minus 6x plus 9. Look at the degree of our functions. In the numerator, I have x to the first power. In the denominator, I have negative 3x squared. In this example, the x over the negative 3x squared, I have the denominator degree being greater than the numerator degree. In this case, I call these guys bottom heavy. because it has a larger degree in the denominator. So we are going to have a horizontal asymptote, and since we technically wouldn't be able to divide these values, it's always y equals 0. So big bottoms give me a horizontal asymptote of y equaling 0. Top heavy give me a slant asymptote, which means no horizontal asymptote. Okay, a few more examples. Let's see how we do. Next one, f of x equals 4 over x plus 1. I don't have any variables in the numerator. That would mean x to the power of 0. Okay, well, we're not going to write that because that looks weird. It would just be 4 times 1, which is still just 4. So in this example, I still have a variable in the denominator, so the denominator degree is larger of the numerator degree. Again, this one's bottom heavy. I have the larger degree in the denominator. This is the easiest one. Horizontal asymptote can't be divided, so y equals 0. You do no work. I love those. Those are my favorite. And our last example, f of x equals x cubed minus 3x squared plus 2x divided by 4x squared minus 36. Look at the degree in the numerator. Biggest exponent is an x to the third. And in the denominator, the biggest term exponent is a 4x squared. This example is top heavy. If something is top heavy, it's going to tilt over. So this one has a slant asymptote, which means there's no horizontal asymptote. So since we're not determining the equation of our slants, you guys in this case can just say no horizontal asymptote for this particular function. Great job. So in the first part of this lesson, we practiced a few more examples for determining the hole. And then in the last few examples, we looked at how to write equations of 2 types of horizontal asymptotes and classifying something as a slant asymptote as well. There are some practice problems for you guys in the next worksheet in your packet for Unit 7. Make sure you practice those and check your answers. Again, you do have a quiz and a test. Your quiz is next week. The test is the following week. Let us know if you have any questions as you're practicing. Have a great day, guys.